Hi students. In the last lecture, I have discussed refraction. Let us now problems based on this. See the first one. A ray of light is incident at the glass water interface at an angle I. It emerges finally parallel to the surface of the water. Then the value of mu of glass. You can see diagram here. From glass, then water, then into air. Okay. See how to start it. Asked for 2 marks in 2003. Right, first make a diagram and this is now air boundary. So this is air and this is water and this is glass. Okay. Now light ray incidents at the glass water boundary. So given angle of incidence that is I. And next coming to here. This is now straight line. If this is angle of refraction R, then here angle of incidence will be R, right? See diagram once carefully. Right. Now, this is angle of incidence and this is angle of refraction. Since the boundaries are parallel, this angle of refraction becomes now angle of incidence for water-air boundary. Okay. So now we have to find mu of glass. It is mu of glass. Then see how to find it. Let us take Snell's law for glass and water boundary. So mu of glass sin I, that is equal to mu of water sin R. Okay. Mu 1, that is mu of glass sin I, that is equal to mu of water sin R. Next, if you take for water and air boundary, so this is now angle of incidence, that is R. That means mu of water sin R, that is equal to, now condition is given that light ray is a parallel to the surface. This is now condition given. That means angle of refraction, it is 90. Then see what we get here. Mu of air, that is 1 into sin 90. That means see what we can write. Mu of glass into sin I is equal to mu of air into sin 90. So here one important conclusion is that whenever boundaries are parallel, we can write Snell's law directly for any two media. That means from this to see what we can write directly mu of glass sin I, that is equal to, it is directly 1 into sin 90. That means this is equation for glass and air. Getting the point. So we are taking for glass and air media. directly. Mu of glass sin I equal to 1 into sin 90. So here we have to understand that since boundaries are parallel, angle of refraction here becomes angle of incidence for this boundary. Angle of refraction at this boundary becomes angle of incidence at this boundary. Relation is boundaries are parallel. That's why whenever boundaries are parallel, we can write Snell's law for any two media directly. That means you no need to worry about this water. Okay. Glass, water, air. We no need to worry about water because boundaries are parallel. So directly from here we can write mu of glass is equal to 1 upon sin I. Okay. Like this, we can solve questions by taking directly for any two media Snell's law. Okay. So option is would be see next one. And this also basing on same point. See carefully. A ray of light passes through four transparent media with refractive indices mu1, mu2, mu3 and mu4 as shown in the figure. The surfaces of all media are parallel. If the emergent ray CD is parallel to the incident ray AB, given CD is a parallel to AB, we must have okay relation. So this again the same point. See carefully once. Given here four media. So medium 1, 2, 3, 4. Okay. 1, 2, 3, 4. Okay. And given so it is given this is AB instant light ray. Next coming to here finally given in this medium it is CD and condition is that CD is parallel to AB. See what is meaning of that? If you take normal at the point of incidence, let us take normal at the point of incidence. And here also take normal at the point of incidence. Okay. AB and CD parallel. Since boundaries are parallel, normals are parallel. I am repeating. Since boundaries are parallel, these two normals also parallel. Condition is given AB parallel to CD. Then angle made by AB with the normal here, angle made by CD with the normal here, both are same. If this is I, this is also I. Okay. Now take Snell's law directly for 1 and 4. Okay. That means mu1 sin I should be equal to mu4 sin I. Okay. Since boundaries are parallel, these two normals also parallel. Since AB and CD are parallel, they make equal angles, means same angles, AI, and this also I only. Okay. That means sin I and sin I gets cancelled. So mu1 is equal to mu4. So basing on same point. Okay. So it is option Option 4, right? Let us see next one more question basing on same point. A monochromatic light is traveling in a medium of refractive index 1.6. It enters a stack of glass layers from the bottom side at an angle theta equal to 30. Theta equal to 30. The interfaces of the glass layers are parallel to each other. The refractive indices of different glass layers are monotonically decreasing as n minus m into delta n, where n suffix m is a refractive index of the mth slab and delta n is 0.1. See diagram. So given n value and I theta value 30, 1, 2, 3, 4 and so on. N minus delta n minus 2 delta n and so on. The ray is refracted out parallel to the interface between m minus 1th and mth slabs from the right side of the stack. What is the value of m? So asked in 2017 advance. And this question also again basing on same point, that is whenever boundaries are parallel, we can write Snell's law for any two media directly. So here condition is that the ray is refracted out parallel to the interface between mth and m minus 1th slab and mth slab. This is m minus 1 and this is m. At this boundary, it is a parallel, right? At this boundary, it is parallel. See, what is the meaning of that? In mth medium, angle of refraction is equal to 90, right? See once carefully. So even though having here so much of data and a diagram, question is very simple one. So we are taking here many layers, and in that we are taking now one layer, that is m minus 1, this is, and this is mth layer. Okay, and here we are taking now, this is, you can say this is one light ray is incident from here, angle is now given 30, and here n value 1.6. And relation is given that it is n means refractive index, n value for mth slab, that is given as n minus m into delta n. And condition is given that, you can see here condition is for m minus 1 and mth slab, it is a parallel to interface. That means we can see in this mth slab, angle of refraction is 90. So here again the same point, boundaries are parallel. So we can write for this medium and for this medium Snell's law directly. So I am writing here n sine theta should be equal to, for mth slab, it is n minus m into, see what is delta n? Delta n is 0.1 into sine 90. So writing directly for this medium and for this medium. Now in this sine theta value, theta is given 30, sine theta 1 by 2, and n value, it is 1.6, this is 1 by 2, again 1.6 minus m into 0.1. This is 0.8. 1.6 minus 0.8. It is 0.8. So m equal to 0.8 by 0.8 by 0.1. That is it. So if you observe in these three questions, same point. That is boundaries are parallel. Then we can write Snell's law for any two media directly. So just matter of one single step. Okay. Right. See next problem. And this question is taken from Hetsi Verma. Consider the situation figure. The bottom of the pot is a reflecting plane mirror. S is a small fish and T is a human eye. Given refract index of water is mu. At what distances from itself will the fish see the images of the eye? Next, at what distances from itself will the eye see the images of the fish? Okay, let us see how to start it. Right, first make a diagram for the given data. So it is now water and air boundary. T stands for eye. Okay, it's a height given from surface of water, that is H. Next, coming to fish, it is inside water at a depth that is given as h by 2. This is given h by 2. And the bottom of the pot, it is a mirror. And this remaining is h by 2. Right. So first we have to focus now. Fish is looking at the eye directly and in the mirror. Okay. Fish is seeing the eye. One is directly looking up and second is in the mirror. Okay. Let us say first part. So for the fish, this distance h by 2, same only h by 2. But coming to h appears to be mu times of h. So we have learned that if object is in rarer medium, then h will be mu times of h. Okay. So here object is now I. Fish is looking at the object. That means fish is now observer. Okay. So object is now in rarer medium. Therefore, for fish, h appears to be mu times of h. So it is now mu times of h. Plus from the fish surface, that distance equal to h by 2. So it is a plus h by 2. This is now distance of the eye from the fish when it looks directly above. Okay. H appears to be mu times because for the fish, eye is now object which is in a rarer medium. Okay. Now in that, this is for fish. Okay. Fish is looking at the bird. Sorry, looking at the eye. That means in eye is now object. I'm writing here. Eye is object. And who is here observing? Fish. So fish is now observer. Okay. So object is in rarer medium. right? Next, again, same. Now fish is looking into the mirror. Okay, then see what happens. Distance of the eye from the mirror. It is distance of the eye from the mirror. See how much it is. This is now h, right? This is h means from surface. This appears to be mu times of h. So mu times of h plus h. That means distance of the eye from the mirror. It is mu h plus h. See carefully what we are writing here. This is now distance of the eye from the plane mirror. I am repeating, its distance from the surface. It appears to be mu times of h. Okay, how it appears? Mu times of h plus this is now h. Total value is mu times of h plus h. This is now distance of the eye from the mirror. And we are knowing that distance of object and distance of image from the plane mirror are same. That means its image will be now below the mirror at same distance. Okay. Now fish is looking at the image of the eye. Its distance is h by 2. Therefore, it is now plus h by 2. That means distance of the eye from the fish h by 2 plus mu h plus h. Okay. This is now distance of the eye when fish is looking at the mirror. Okay. Next. Now in this second part, eye is looking at the fish. That means eye. Eye is now observer. Eye is now observer and fish is object. That means now object is in denser medium. Object is in denser medium. So in that case, for the eye, this fish appears to be at a depth of h by 2 by mu. So I'm writing the first part here. H by 2 appears to be 1 by mu times. Okay, because object is now in denser medium. So h by 2 that appears to be 1 by mu times plus its distance from the surface is h. So plus h. It is now h by 2 mu plus h. That is now distance of the fish from the eye when eye is looking at the fish directly. Now in this second part is second part is if eye is looking at the fish in the mirror. Okay, if eye is looking at the fish in the mirror, then see what happens. Distance of the mirror from the eye. This is depth equal to h. This h appears to be, or we can do one thing, image of the fish. Image of the fish from the mirror. It will be h by 2 behind the mirror because a plane mirror forms a virtual image. So distance of object h by 2. Distance of image also h by 2. Okay. That means distance of the fish, or I can say distance of the image of the fish from surface of water is, this is a h and this is now h by 2. So total is now 3h by 2. This is now distance of the image of the fish from surface of water. And this appears to be 1 by mu times. This appears to be 1 by mu times plus this is equal to h. So plus h. So that is equal to 3h by 2 mu plus h. That means this is the distance of image of the fish in the mirror from the eye. So we have to focus which is observer and which is object. So object is in rarer medium. It appears to be mu times of the actual distance. It is object is now in denser medium. Then distance will be 1 by mu times of the actual distance. Right? So if we have this clarity, we can solve the question directly. Right? See next problem. See what is the question given. A ball is dropped from a height of 20 meter above the surface of water in a lake. The refractive index of water is 4 by 3. A fish inside the lake in the line of fall of the ball is looking at the ball. At an instant when the ball is 12.8 meter above water surface, the fish sees the speed of the ball as, see how to calculate this. Initial height given 20 when it is 12.8 above surface of water. That means see how much distance it has covered. 20 minus 12.8. That is 7.2 meter, right? Right. So first note down the given data. So it is given that suppose this is surface of water, height of the ball initially given 20 meter. At one instant, it is given as 12.8 meter. And the fish is now in the same line looking at the ball. See how much distance it has covered. 20 minus 12.8. That is 7.2 meter. At that instant, velocity of the ball, it is now freely falling body. So velocity equal to 2gh, right? Root 2, g value 10. It has covered 7.2. 72 into 2, 144. This is 12. 12 meter per second. So at that instant, its velocity is 12 meter per second. Okay. Now see carefully here. Now here what I am doing is, let us take this as y-axis. Vertically up as y-axis. Okay. Now distance of that point from the fish. Suppose this is y naught, which is a constant, but coming to y, it is changing. Okay. So I'm writing here distance of the ball from the fish. Distance of the ball from the fish. It is y naught plus y. If you differentiate this, if you differentiate this, but remember when we are taking here y distance, since a ball is now object, this y appears to be mu times of y. Okay, so here we have to write in the place of y, it is mu times of y. Okay, because ball is object, this y distance appears to be mu times of y. So mu into y. Derivative of that gives velocity of the ball as absorbed by the fish. Okay. See what is that? Y naught. It is a constant because the fish is not moving. Derivative 0. Next. Derivative of mu y. Mu y. I am taking mu outside. dy by dt. Okay, the rate of change of y. So this is giving us velocity 12.8 distance at this instant velocity how much 12 and mu value given 4 by 3. Okay, and this is now 12. In fact, we have to focus sign convention also. Here y coordinate is decreasing, right? That means dy by dt itself is negative. Okay, then we should take here negative of that, and this is equal to 12 meter per second. Okay, so 4 by 3 into this is actually negative of dy by dt. So this is now I'm taking that is speed. This is 4 times 4 16 meter per second. Okay, so what is the value of dy by dt? dy by dt, that is minus 12 meter per second. So here we should take actually minus 12. Okay, but here we are calculating only speed. Okay, speed means modulus of that, and why we got negative means velocity is downwards, that's why it is negative. Okay, anyhow they're asking only speed, it is 16 meter per second. If they ask direction, it is downwards. Okay, so it is option C, right?